Preprocessing is a series of operations that is performed and the digitized input image to improve the image quality for efficient features. The main stage of the pre-treatment are as follows: noise removal, binarization, morphological operations, and size normalizations. Incursive handwriting ligatures are ideal segmenting point algorithms are different. There are implicit based and explicit based. In implicit segmentation words are predicted directly without segmenting the word into individual letters, but explicit segmentation. The word is segmented into individual characters. The future extraction is the most vital, and therefore the future should be extracted correctly that decides the effectiveness of the classification. Future extraction method as classified into the major groups: statistical futures, global transformation and series expansions, structural futures. Classification is the decision-making part of any recognition system. Various approaches for classification in character recognition systems are analyzed. Most commonly seen classifiers are ANN, SVM, and KNN. The classifier compares the given vector with the stored pattern and given the best match as an output. In contrast of classical technique, deep learning algorithms provide a complete solution to handwriting Arabic text recognition without any artisanal extraction technology. Deep learning is a subset of machine learning in artificial intelligence that has network capable of learning unsupervised from data that is unstructured or unlabeled. The advantage of deep learning over machine learning is this needlessness of the future extraction. The performance of deep learning algorithms tends to improve exponentially when they are given more trying more tried data and the analysis. The state-of-the-art research addressing the issue of handwriting Arabic text recognition generally fall on, into the following main categories. Traditional approaches and basic deep learning approaches. In traditional approaches, based on the engineer's expertise to extract representative features, the method classification by machine learning methods like SVM, super vector machine, multi-layer perception, random forest, and decision tree. On the other hand, the approaches of deep learning for the classification using the recognition of handwriting text are numerous as deep belief networks, deep recurrent networks, deep Boltzmann machine DBM, and deep convolutional neural networks. So, table 3 is presents the result of the recognition of recently published systems of the dataset IFN-ENIT. We start by comparing the two works which propose a recognition system based RNN in particular, multidimensional long short-term memory. The dropout regularization technique improves the accuracy rate. The dropout technique has shown in its advantage through the CDBN method compared to the combination of CDBN and DBN. The work based on the architecture of CNN show that the combination CNN and RNN achieve a very good rate of accuracy compared to the other method of CNN and CNN DBN and the combination CNN DBN. Another comparison of recent work on the dataset of HECDB presented in table 4. First of all, the discrete cosine transform technique introduced with INN for the extraction of characteristics. A new model is proposed based on the integration of two classifiers, SVM and CNN. The principle of this model and the modification of the format of the CNN by SVM, which aims to extract a representation of the data via several layers. A VGGNet model of 13 convolutional layers and 2 max poly layers, the fast and reliable model, which improves classification performance. We present at the end of this table 3 works of the sum round which integrates the dropout and drop connect regularization techniques with DBN and CDBN. The combination of the two techniques achieve a very good accuracy for character recognition comparable to the start of the art. So the recognition of handwriting text is a very active field of researchers with constantly requires an improvement in precision. In this article, we have presented the deep learning approaches for the recognition of Arabic writing, namely algorithm-based RNN, DBN, and CNN. In the other hand, we have presented chronologically tables of work based in 2 databases containing a comparison between the different deep learning methods and technique followed by the research. To advance the state of the art recognition, Arabic handwriting, we definitely need large databases for Arabic handwriting. Our present research highlights the main works used for Arabic handwriting recognition based on deep learning. We insightfully plan in the common works to ultimately improve the recognition rate of handwriting Arabic historical document using deep learning approaches. Thank you for your attention.
Thank you, Mr. Hisham Lamtouki, for this very informative presentation. It was very clear and very informative. So now we go to questions from the audience. So is there some questions to Mr. Hisham?
Hello.
Hello, please present yourself.
I am Nabil Aqad, professor at National School of Applied Science of the University Sidi Mohammed bin Abdullah.
Hello, Mr. Nabil. You are chair with me in this session. Hello. Okay, you can ask your question, Mr. Nabil.
Thank you. Hello, dear professor, colleague, dear PhD students, dear participants. Thank you for your nice presentation, Mr. Hisham. I have some simple question about your presentation. The first one is, have you implemented these different methods or only you taken the results?
Okay. Oui.
If yes, do this article use the same characteristic, the same parameters, etc.?
No, monsieur. I don't implement this article.
You take only the results of the different article that you presented?
Yes. Yes.
Yes, but
Yes.
If this article use the same database, the same parameters, the same characteristics, I don't know.
Your question, Mr. Please. I don't. Your question.
Mr. Hisham, we don't. Please,
Don't
please
hear you.
talk.
Repeat your question.
Hello, Mr. Hisham. We cannot hear you. We cannot hear your voice.
Yes.
Please
yes.
repeat. Please repeat your answer.
Your question, please, Mr. I don't repeat your question, please.
My question is, I repeat my question. My question is, have you implemented this different method?
No,
or
no.
You take the results?
No, no. I don't implement this result.
I can't hear you, Mr. Hisham.
Mr. Hisham, Professor Nabil asking you if you are reproducing all the results presented in your work, or just is a literature overview.
No, it's seulement des résultats que j'ai obtenus.
Mr. Hisham, we cannot hear you. Maybe
we can't hear you.
Please repeat your answer. We cannot hear you clearly.
Yes. Donc, it's different.
Moment, Mr. Hisham, please. I am asking the audience to close their camera in order to keep the.
My camera is closed, Mr.
Yeah, Mr. Nabil Akkad, please close your camera because we have a problem of connection.
Yes.
Please, everybody, please close your microphone, your camera. Only the when you will ask your question, please activate your microphone. Okay. Okay, you can give the answer, Mr. Hisham.
Okay. It's work. I'm focused on comparison different methods of deep learning.
I can't hear you.
What, Mister?
I can't hear you.
Please repeat your answer, Mr. Hisham.
Okay. In this work, I am focused on comparing the different methods of deep learning. In order to differentiate between only the method of deep learning, its algorithm, which is obtained the best result of some databases.
Okay. I hope Mr. Nabil, do you have another, Mr. Nabil, are you some other questions?
But you didn't present database that you used.
What?
You didn't present the database that you used for this different method.
Yes.
Mr. Hisham, do you hear me?
Yes.
Yeah, can you tell us about your database used in your work? Which
Yes,
database
yes.
are you using?
Okay.
Please go to the slide in which you
Databases.
your
Okay. 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 All right.
okay. Okay.
Okay.
Are you using all those databases or just
Two databases.
few of them?
No. So I use two databases. Are the most efficient and rich is IFN, ENIT, and ECDB. Donc, I use the two databases. Donc, are the most efficient and rich compared to the other and also available for research. Another reason is that each ECDB database of character and if IFN ENIT, it's a database contain the text. So is diversity of data. Okay. Donc,
Okay.
there are other data sets like DEHCL, but the database, the work of these databases is weak, right?
Okay, Mr. Hisham. Okay, Mr. Nabil, do you have another? Maybe.
Thank you, Mr. Hisham. The last question. Have you
Okay.
tested this approach in the presence of noise?
No. Mr. Nabil.
Yes.
I also inform you that it's me my first year. Donc,
Yes. Okay, Mr. Hisham.
Thank you, Mr. Nabil.
Thank you very much. Thank you very much, Mr. Hisham.
thank you,
very much,
Nabil.
Mr. Hassan.
Thank you.
Okay, thank you, Mr. Nabil, for your very interesting questions.
Thank you,
Is there some other questions? I'm asking audience. Please,
Yes, Chairman, please. I ask a question.
Okay, Mr. Aksas Hamid, please, you have the floor. You can ask your question.
So first of all, I would like to introduce myself. I'm a PhD student. My name is Hamid Aksas from Faculty of Science and Technique in Rashidia. So firstly, I would like to apologize because I didn't attend the presentation from the beginning. I followed the presentation at the conclusion, but I saw that Mr. Hisham used the convolutional neural network. So I would like, if it's possible, to give me the architecture of the CNN you have used.
Okay. Okay, Sir Hisham.
Yes.
You get the question?
No.
Please repeat the question, your question, Mr. Hamid.
Okay, I see that I saw at the end of your presentation that you have used some deep learning models, such as convolutional neural networks. So I would like to have some information about the architecture of the CNN you have used.
Yes. This work is a study which contains the most recent.
Mr. Hisham, we cannot hear you. Please repeat. We cannot hear your voice.
Yes. This work, Mr., is a study which contains the most recent work for the new technology deep learning and makes a comparison between the most illustrated works for handwriting Arabic text recognition. Therefore, this work and a study for the research of these files.
So, if I understand, there was no any implementation of a model.
My model?
Is there an implementation or
No,
or
no, Mr. No.
Okay,
So,
okay.
Donc, it's study. Donc, my contribution, we build direct the processing of historical document, inshallah.
Okay, good luck, Mr. Hisham.
Thank you, Mr. Thank you.
Thank you, Mr. Hamid, for your question. Is there some other questions?
J'ai Professeur Hassan Satori.
Yes, please present yourself.
Professeur Sabri. Je vais continuer en français pour mieux faire passer l'information. J'espère que c'est pas dérangeant.
Okay, no problem. You can ask in French, no problem.
Donc, c'est Hichem Mtsougi. Donc, je te félicite pour la présentation. D'accord. J'aimerais bien, c'est pas poser, c'est plus donner des conseils que poser des questions. D'accord. Donc là, on est devant une présentation qui fait, c'est-à-dire une étude littéraire de la littérature sur les approches utilisant donc la reconnaissance des caractères manuscrits, ainsi de suite, arabe.
Oui, monsieur. Oui, exactement.
Utilisons les approches apprentissage automatique et apprentissage profond. D'accord.
Oui,
donc,
monsieur.
les questions posées par les professeurs et le doctorant Aksas Hamid sont vraiment très instructives du fait que ce qu'il manque dans votre présentation, c'est le fait de préciser les datasets utilisés. C'est-à-dire que tu as dit que vous avez utilisé 2 bases de données.
Oui.
D'accord. C'est pas vous avez utilisé que les approches présentées ont utilisé les 2 bases de données. Donc, alors que on ne peut pas comparer la précision sur des approches n'utilisant pas les mêmes caractéristiques, premièrement. Deuxièmement, vous avez présenté plus les algorithmes de l'apprentissage profond et les techniques, alors qu'il fallait mettre l'accent sur la reconnaissance des caractères manuscrits, les problématiques, ainsi de suite. Et à la fin, après une étude comparative, il fallait faire une synthèse. C'est-à-dire, l'objectif de l'étude comparative, ce n'est pas de lister les travaux qui ont été réalisés dans des contextes, mais à la fin de faire une synthèse, c'est-à-dire préparer l'étape suivante. Sinon, ça ne sert à rien de faire une étude comparative, une étude littéraire. D'accord. Donc, à la fin, qu'est-ce que vous avez compris ou bien qu'est-ce que vous avez constaté de cette étude comparative pour passer à l'étape suivante, apporter des solutions. D'accord. C'est ce qui manque dans votre présentation. Et il faut vraiment, ça va pour les prochaines présentations, améliorer ce petit détail.
Inch'Allah. Merci, monsieur. Merci.
C'est bon. Et alors, bon courage. Merci.
Merci, monsieur. Merci. Merci. Thank you. Merci.
Thank you, Mr. Abdelwahed. Thank you for your advice for our PhD student. So, is there some other questions? Please, if you have some question, please activate your microphone and start talking. No other questions? So, if there are no questions, we move to the first presentation. Mr. Marwan El-Mansouri, are you here? I'm asking Mr. Hisham to leave the presentation. Okay. Mr. Marwan El-Mansouri. Mr. Badr Aghutan, do you hear me?
Yes, Mr. Hassan, I hear you. And Mr. Mansouri is here. I ask him if he is ready to begin his presentation because he has some technical problem.
Okay. If he need more time, we can move to the third.
Okay. It's be better. Next presentation, please, and we can be ready to present our work. Thank you, Mr. Hassan, and sorry for this problem.
No problem. We can understand the technical problem. So I'm asking Mr. Nabil Aqad to ask next the third one to come. Do you hear me, Mr. Nabil? Nabil Aqad? Professor Nabil? Maybe he don't hear me. So I am asking Mr. Abdurrahim Izzin.
Yes, Mr.
Come.
Hassan.
Mr. Nabil,
Yes.
do you hear me?
Yes, yes.
Okay, you can take the floor and ask the next author to come. The third one.
Yes, we switch to the third, I think, presentation.
Yes, the third one of the session number 6.
Yes, that will presented by, I think, Abdurrahim Zin.
Yes.
Abdurrahim Zin, you can share your presentation, please. You are here, Abdurrahim, Mr. Abdurrahim.
I can to introduce my presentation.
Mr. Abdurrahim.
Yes, I'm here.
Abdurrahim, the others are Abdurrahim Zin, Hassan Satori, Mohammed Hamiddin, and Khalid Satori.
Welcome.
Abdurrahim, you don't hear?
Can you hear me? Can you hear me?
Mr. Abdurrahim, you are here?
I have, yes, I'm here. Can you hear me?
Yes, you can share your presentation.
Can you hear me? Okay, so welcome to you. Welcome to you in this presentation. First, I want to thank my supervisor, Hassan Satori, who really directed my thoughts to right track. Also, I thank my colleague, Hamidi Mohammed. So, concerning our work is entitled Moroccan Dialect Speech Recognition System based on ISCV Speak Source. So in this presentation, we will talk about automatic speech recognition system.
But Mr. Abdurrahim, we cannot hear you clearly. Please, please make your voice more clear. ما كنسمعوكش أستاذ عبد الرحيم، قرب الميكرو لعندك.
Okay. دابا مزيان؟ Hi, you can hear me?
Yes,
No.
yes.
Okay.
My Professor Hassan, you can hear me?
Yes, yes, yeah. Okay.
So in this presentation, we will talk about automatic speech recognition in the introduction. And in the second part, we propose our system. Next section, it will be before discussion of experimental results. In the end, it will be for conclusion and perspectives. Automatic speech recognition is the research domain that tries to make machine mimic human in producing and react to speech. In brief, automatic speech recognition is a system that transfers the human speech from an audio to the text. As you see in this figure, this list of recognized words can be used in command interactive voice recognition.
Mr. Abdurrahim,
control. It
Mr.
is
Abdurrahim.
a technology that.
Mr. Abdurrahim, we can't hear.
Yes.
Please move your slide. The slide is fixed.
Yes, Professor.
Your slide is fixed in the number 2.
Is fixed?
Yes.
No?
Okay,
No?
Yes, yes, ma'am.
it's still fixed.
No.
Now it's okay. Now it's okay.
No?
Go
Yes,
go ahead.
yes.
Go ahead. Okay, continue, Abdurrahim.
It's okay?
It's okay, it's okay. You can continue. Mr. Abdurrahim, you can continue.
Maybe he have trouble. He have problem with his presentation.
Yes, problem the connection.
Mr. Abdurrahim, do you hear me? Please leave the presentation and upload it again. Please. Hello, Mr. Abdurrahim.
I think that he doesn't hear. He writes, sorry for the last messages.
Okay, maybe we will move to the next presentation. He have also the technical connection problem. Please, audience, I am asking the audience to close their camera because it consumes our connection. It causes problem. Please close your camera. Professor Hamid Tahiri, please close your camera.
I think we switch to the last presentation.
Okay.
Yes. Fedwa Bakari.
Oui, est-ce que vous pouvez m'entendre?
Yes. Please share your presentation. You have 15 minutes to present your work. Please, you can start.
Good morning, everyone. I will present the Amazigh Exalted Word Speech Recognition System using the Adaptive Orthogonal Transform method. The Amazigh language is considered the oldest and the most used language in North Africa. In Morocco, about 50% of the Moroccan population uses this language in their daily life. It can be classified into 3 types: Tarifit, and Tamazight, and Tashilhit. Since 2003, the Amazigh language has been introduced into the education system as a subject in primary schools, the media, and the faculties. The goal of this research is to develop a method and an algorithm for the speech recognition of Amazigh Exalted words. There are several methods that are used in signal processing for automatic speech recognition, such as principal component analysis, empirical model decomposition, and discrete wavelet transform. But the problem with them is that they need a large database to get satisfactory results. And to solve this issue, we have found a new approach based on the adaptive orthogonal transformations for the extraction of the informative features from the speech signal with a technical method to remove silence and to detect the beginning and the end of speech utterance. The presentation is organized as follows. The first tank, I will present the existing methods, the principal component analysis, empirical model decomposition, and discrete wavelet transform. Then I will detail the new approach of orthogonal operators. After that, I will present the comparison results obtained between the existing methods and the new approach. And finally, I'm going to conclude the presentation with a little conclusion. Now I'm going to start with the existing methods. The first one is the principal component analysis. Principal component analysis, or PCA, is a statistical procedure using an orthogonal transformation to reduce the number of features without losing too much information. Then we have the discrete wavelet transform, or DWT, that decomposes the signal into wavelet coefficients from which the original signal can be reconstructed again. The wavelet coefficients represent the signal in various frequency bands. They can be processed in several ways, giving the DWT attractive properties over linear filtering. And the last one is the empirical model decomposition that adaptively and locally decomposes any non-stationary time series in a sum of intrinsic mode functions, which represents zero mean, amplitude, and frequency modulated components. Unlike short-time Fourier transform and the wavelet transform, the MD can decompose non-linear and non-stationary signals. Although these methods have several advantages, they have reached their limits in the improvement of automatic speech recognition systems. For example, the discrete wavelet transform gives good results only if you choose a compatible type of wavelet with the input signals. And the principal component analysis is based on a very complicated calculation, so the execution of the algorithm will take more time if the size of the input signal is large. And the empirical model decomposition does not adapt the analyzed signals. Therefore, we cannot create an adaptive operator based on them. So all of these approaches need a long execution time and a large voice database to have satisfactory results. That's why we need a fast algorithm to detect the informative characteristics of the voice signal using the smallest database. After so many researches, we found a method to solve these issues by using the adaptive orthogonal transformations for the extraction of the informative characteristics of speech signals to relate a system for detection of ambiguously resolved word speech with a technical method to remove silence and to compress speech signals. But before starting to apply our method, we should first prepare the signals. The first thing to do is to remove the silence from them by using the zero crossing rate, ZCR. Zero crossing rate of any signal frame is the rate at which a signal changes its sign during the frame. It denotes the number of times the signal changes value from positive to negative and vice versa, divided by the total length of the frame. After the calculation of ZCR, a signal is reconstructed without silence and with a detection of the endpoint when frames maximum value are strictly higher than the zero crossing rate. After removing the silence and detecting the endpoint, the database can contain several signals that do not have the same length. To solve this issue, we should find the signal that has the maximum length, and we will assign this length to the other signals by adding zero at the end of them until we reach the desired length. This method called zero padding. After using zero padding, there is a probability to have a slow algorithm if the database contains long signals. But with the Fourier transform or the correlation, we can avoid this issue by working with intervals that have important information instead of working with the whole signals. In digital treatment, transformed shelf space orthogonal of a signal x can be represented by the following matrix: y equals 1 divided by n multiplied by each x, where x is the initial signal to be transformed, and y is the vector of the spectral coefficients. Factorization of Wood showed a possibility of representing the matrix operator H as product Gi, as is shown below. It's a sparse matrix with a higher proportion of 0, which has allowed the construction of the quick transformation algorithm of Fourier, Haar, and Walsh. Hence, the equation 1 can be written as follows. The operator H is the scalar product of Gi, and we will multiply it by the initial signal x. The operator adaptation allows to get the target vector yt having the following form, where the first element is non-zero. The calculation of the target vector yt is according to the following equation: gi multiplied by yi minus 1 gives a vector yi where the first element is non-zero and the other are equals to 0. The following figure shows a sample example of how our system works. For example, if we have 100 signals in the training dataset, the first thing to do is to compress the signal by removing noises, silences, etc. And from the average of first 50 signals, we calculate the operator h. Then we multiply it by the rest of the signal, that is from 51 to 100. After that, we will get 50 characteristic vectors, and we calculate their averages. And for the test signal, the same steps are carried out. Then the vector obtained from the test signal is compared with the vector obtained from the training dataset by calculating the Euclidean distance between these two. Dataset contains speech signals recorded and filtered by the program Audacity. It consists each class contains voice recording of Amazigh adulthood word speech produced by several speakers. The first one contains the voice recording of the word atbir, pigeon in English. The second contains the voice recording of the word agru, frog in English, and the third contains the voice recording of the word sin, two in English. The number of voice recordings for each class of the training dataset is 100, and the test dataset contains 300 voice recordings of Amazigh adulthood word speech pronounced also by different speakers. And as I said before, to compare the similarity between the word in the training dataset and the word in the test dataset, we use the Euclidean distance. When the distance between the I vector of the spectrum X and the I vector of the spectrum Y is minimal, that means that they are similar, and if not, it means that they are not similar. The recognition is measured by calculating the recognition rate given as follows: the exact word count divided by the rest dataset size multiplied by 100. The rate used in our approach is 97.3%, and the rate obtained using the methods PCA, GWT, and EMD are 59.5%, 62.1%, and 64.0%. The experimental results show that the Amazigh adulthood word speech recognition system using the adaptive orthogonal transform method is more efficient and gives satisfactory results than other existing approaches. As a conclusion, we conclude that the adaptive orthogonal transformation is one of the most efficient methods of the speech recognition that gives satisfactory results and a fast algorithm, even if we have a training dataset that contains fewer signals compared to the test dataset. This approach can solve several classification problems in various fields, such as object recognition system, medical diagnosis system, and voice prompt recognition system, etc. And finally, I would like to thank all organizing committee members of International Conference on Intelligent Systems and Computer Vision, and thank you for your attention.
Mrs. Fdoua, thank you for your presentation, for your nice presentation. We move now to question. Please, if you have the question. Yes, I have one question, Mrs. Fdoua.
Oui.
Why the choice of this database?
Je peux pas. What did you say?
Why the choice of this database?
Est-ce que je peux répondre en français pour
mieux? Oui, tu peux répondre en français. Pourquoi le choix de cette base de données et pas autre base de données que celle-là?
Cette base de données, j'ai fait la base de données par moi-même, c'est-à-dire que j'ai enregistré les enregistrements vocaux de d'autres personnes. C'est ma base de données. J'ai trouvé d'autres bases de données, mais pour la langue amazigh, il n'y en a pas des bases de données sur Internet qui sont concernant cette langue. Pour le nombre de la base de données, j'ai fait pour les enregistrements vocaux de la base de données test, ce sont 300 enregistrements vocaux pour chaque mot. J'ai fait le test sur 3 mots. Puis pour la base de données, j'ai fait 100 enregistrements vocaux pour chaque mot. C'est ça, 100 pour la base de données et 300 pour la base de données test.
Oui, mais est-ce que vous ne voyez pas que ces données ne sont pas suffisantes pour tout simplement la reconnaissance vocale?
Oui, c'est vrai. Et pour cela, pour mon prochainement projet, je veux augmenter le nombre des signaux de la base de données, aussi de diminuer le nombre de signaux de la base de données test. Aussi, je veux faire aussi la comparaison avec d'autres approches comme Markov, comme les réseaux de neurones, etc.
Oui, il faut penser aussi à l'utilisation d'autres bases de données.
Oui.
Ok, merci, mademoiselle Fedouard.
Merci à vous.
Est-ce qu'il y a d'autres questions? Oui, monsieur le professeur Hassan Saton.
Yes, I have many questions to Fedwa. So I would like to thank her for his work and his for her work and her presentation. Very clear and very informative. But I don't agree with you with your conclusion. So I would like to remember that I was I have the chance to be one of the reviewer of your paper, and I made some remarks for you. So I have some misaccordance with you because we are working on we are doing also speech recognition, and we have some experience in this area. So we can share our knowledge together. So in your conclusion, you said that your method of the orthogonal transformation method is the best one. I don't agree with you. So the method now, the powerful method existing in the literature are the HMM. I'm asking you, yes, hidden Markov models are the powerful system, and all international systems made commercial or open source are based on HMM, and the literature, more than 80% of literature are talking about this. I'm asking you to search. Is it your first year?
Oui, c'est ma première année pour le modèle de Markov. J'ai déjà étudié quelques articles et aussi j'ai observé que ils sont basés pour Markov aussi. Il est basé sur plusieurs calculs statistiques et aussi les probabilités. Donc, je ne sais pas, est-ce qu'il va donner des meilleurs résultats avec un temps d'exécution qui est rapide, ou bien aussi on va avoir un problème au niveau de temps d'exécution de l'algorithme. Pour cela, je suis en train d'étudier ce modèle pour faire aussi la comparaison entre cette approche et Markov.
Non, mademoiselle. Donc, je suis pas donc pour dire que les modèles de Markov qui sont opérationnels depuis plus de 50 ans et tout le monde l'utilise jusqu'à maintenant. Alors, je te dis donc les grandes firmes qui fabriquent les systèmes de reconnaissance automatique, Microsoft, naturally speaking, and Apple et les grandes firmes se basent sur la technique des modèles de Markov. Donc, c'est la plus puissante aujourd'hui. C'est la littérature qui dit ça. Donc, tu dois comparer avec tu dois faire des comparaisons avec quelques articles. Alors, donc ça c'est un point. Donc d'autres points. Donc I prefer to continue in English in order to keep the international aspects of the conference. We should ask our question in English. So my second remark is concern your words, the chosen words that you are working on. You don't specify which one. Are you working on digits or some? If you should add the list of or some sample, some example of the words you are recording.
I did it. I said that I compare the word frog and two and pigeon.
You don't give a list of words. The example, the words. Is it digits? Is it some words come in? Which word are you using in your experiment?
I use the word for a frog, that is agro in Amazigh language, and sin, that means two, and also I used sin two and sin.
How many words?
3 words, just 3.
6 words?
No, 3.
No,
3.
3. Only
yes.
3.
Only 3.
Only 3 words, and you are using 3 words, and you feel that your method is the most powerful, and you should make more efforts and add some additional words. The words that you are choosing are.
I worked with 3 classes.
3 classes.
3 classes, yes.
Can you show us the list of words, the database list, the dictionary?
Okay. Database. This is one of them. Are you see my screen?
No, we cannot see. Only the last slide. We can see only the last one.
How can I?
Please move.
I don't know. This is one of them.
No, I'm talking about the words. The
words. I didn't
شنو هما الكلمات اللي استعملتي؟ شنو هما الكلمات؟
The word I say that I use the word agro and the word sin and the word atbir. 3 words.
Only 3 words.
Only 3 words.
It's not sufficient.
And for such word, this is agro, atbir, and sin.
It's not sufficient. You have to choose your words very to be sure that the words contain all phonemes of Amazigh and all syllabs. You should choose your words with some rules. There are some rules when you are preparing some your automatic speech recognition, you have to follow some rules. You don't have, you cannot choose randomly 3 words and you can tell to and prepare your paper and tell that your system is performance. I have results, and no, it's not sufficient. In other side, your database you have to separate it in 2 parts. The first part is for training. It's about 70% of your database, and the test is 30% of your database. It's also a criterion that you should respect in order to have some standard and to follow the standard to tell that your system is performant or not. So you have to take into consideration all remarks that I give you in my letter when I prepared the review. When I sent you a list of remarks. It contains also this remark that I tell you now.
No, so it's not in. It's not between them.
Okay, I can also share with you my email, and you can contact me if you need more discussion about this.
Thank you so much.
So it's my last question. So I give the floor to Mr. Nabil for other questions. I think Mr. Ibrahim have a question. Mr. Ibrahim Aksas.
Yes, do you hear me?
Oui, I hear you.
Okay, good morning, everyone. Thanks to the organizer of ISCV 2020. Thanks for Mrs. Fadwa for her work about ISR for cognition separated words in Tamazight. I have a little question about the complexity of the adaptive orthogonal transformation. The complexity, because when we develop omitted, we think about its implementation in real time. What do you say about the complexity compared to the PCA, the WT, and the decomposition? It can be implemented in real time or on different time? Thanks for answering this question. Thanks for the organization.
I said before that other methods are also efficient, are also efficacious, but they are also reached their limits. For example, for discrete wavelet transform, it gives good results only if you choose a compatible type of wavelet. And the principal component analysis, it's also a good method, but it's based on a very complicated calculation. So the execution time of the algorithm take more time. If the size of the input signals is large. And for the empirical model, decomposition does not adapt to the analyzed signals. For that, we cannot create an adaptive operator based on them. I don't know if I answer your question or not.
Okay, thank you, Fadwa. So I just got a call from the organization committee of conference that we consume a lot of time. So we should move to the next, Mr. Nabil.
Thank you very much, Professor Hassan Satori, for your advice and your relevant remarks. Yes, we were late in this presentation. We must move to another presentation. Prof. Agoutan Badar, Professor Agoutan, you are here?
Yes, Mr. Nabil, I'm here, and thank you for your comprehension. I
Thank
think
you
that
again.
Mr. Mansouri Marwan is ready to present his work. Thank you for your comprehension. I thank also the committee of organization, and sorry for this technical problem, and I give the floor to Mr. Mansouri Marwan to begin his presentation. Thank you. Thank you.
Thank you very much.
Thank you
Thank
very
you very
much.
much, Professor Badruddin. Thank you.
Okay, Mr. Marwan, please don't exceed 10 to 15 minutes because we don't have enough time.
Okay, thank you. Can you hear me?
Yes, yes, you can start.
Okay. Hi, everyone. I present myself. My name is Marwan Mansouri. I am a student from Faculty of Science in Moulay Ismail University of Meknes. Today, I am going to present for you this work, which talk about Arabic words classification using deep learning technique, titled by two-word classification of Arabic manuscript words based on the deep convolutional neural network. Before starting, I would like to thank the committee members of the fourth International Conference on Intelligent System and Computer Vision for their efforts to success this conference. I would also like to thank the reviewers for their marks. Finally, I would like to thank my supervisors for their professors Nordin Al-Makhfi and Badruddin Aghotan for their patience, availability, and especially for their wise advice, which helped to fuel my thinking. For this presentation, we have five primary parts. Firstly, an introduction in which we will talk about our goal of this work. Secondly, in the part which concerns related works, we will introduce some projects that have been developed for different kinds of hand-writing. In the third part, we will describe our proposed methods. Next, in the results, we will provide the results obtained by these methods. Finally, the last part, we will focus on the conclusion. Starting with the introduction. Arabic language is one of the most popular spoken language in the world, where it is used by hundreds of millions of people, and it is an official language in more than 16 countries, since the Quran and the Hadith are written by the Arabic language. Moreover, in contrast to the Latin language, which is written from the left to the right, Arabic language is written from the right to the left using 28 alphabets. These alphabets are often confusing, and that is due to the different writing styles. But sometimes that can be shown by the same writer. The figure in the right position shows some examples of words which are confusing and written by the same writer. However, over the years, the handwriting researchers have developed and proposed several techniques for word spotting, word recognition, and other problems in this field to deal with these confusing words. For this reason, in this work, we propose two classification systems based on the deep learning techniques. The first one uses a neural network, and the last one uses a convolutional neural network. Moving to the next part, which is concern related works. In this work, we could separate the previous methods into two categories: traditional methods and the modern methods. The difference is that the traditional methods use traditional techniques such as feature extractor and feature descriptor like shift and surf. On the other hand, the modern methods use intelligent techniques such as deep learning techniques like neural network and convolutional neural network. The experiment results have shown that the modern technique could outperform the traditional methods. hence the idea of this work to use for using deep learning techniques. Proposed method. Our proposed method consists of two steps or two stages. The first one is segmentation, and the last one is classification systems. Segmentation steps. Our segmentation is based on three steps. The first one is to convert the original color image to a grayscale image and transform it to a binary image using threshold between 17 and 100. Next second step is to apply the projection function, which is defined by the equation 1, where E of xy is the binary image and y is the weight of the image. And the last step is to apply the same function, but this time on the horizontal axis. This figure shows the results of using these three steps. Moving to the next step of proposed method. Before describe our proposed classification systems, I would to give you a short definition of neural network and convolutional neural network. Starting with a neural network. A neural network, also known as a multi-layer perceptron, is a class of feed-forward artificial neural networks. A neural network is usually composed of at least 3 layers of perceptrons or neurons, which are an input layer, a hidden layer, and an output layer, as you can see in this figure. This type of technique works in three types. The first one called forward propagation, in which we distribute the input values into the next layers in order to calculate the output. Next step is called loss, which help to compute the difference between the calculated output and the real output. The last step is backward propagation, which help to update the weights and the bias of this neural network in order to complete the training. In this slide, we will give you a short definition of convolutional neural network. A convolutional neural network are a specialized type of neural network, often used in computer vision tasks like image classification, face recognition, and object detection. This type of multi-layer perceptron is generally composed of 3 kinds of layers: a convolutional layer, a polynomial layer, and fully connected layer. A convolutional layer is the heart of a convolutional neural network, which allows it to learn linear features. As its name indicates, this type of layers uses the mathematical discrete convolutional operation, which is defined by the equation 2. The right figure gives us and illustrates how this operation works. A Polynomial layer or subsampling. After computing the convolutional layer, we added a specific type of layer called Polynomial that abstracts the input feature into a lower dimensional feature. There are several nonlinear functions to implement Polynomial, such as max Polynomial and average Polynomial. Among them, max Polynomial is the most common, which helps to keep just the maximum value. In this slide, we describe our proposed neural network architecture. Our neural network contains 5 layers. An output layer of size 10,000 neurons or perceptrons, an output layer, and between the input layer and the output layer, we attached 3 hidden layers of size 512, 256, and 128, respectively. For our second model, it contains 7 layers, an output layer, an input layer, and between them we use 5 hidden layers, 2 convolutional layers followed by a Rollo activation function, and 2 max pooling. Results. These figures shows the evolution of our training for neural networks. The right, the left concerns the loss or the error rate, and the right one concerns the accuracy. And in this slide, we shows the figures which shows the evolution of our training for the convolutional neural networks. Conclusion. In this research, we proposed some method for Arabic manuscripts word classification. Using the Hadara datasets, we could obtain an accuracy up to 98.42% on the Hadara datasets. This is some reference that we have uses to complete this work. And thank you.
Thank you very much, Mr. Marwan, for your presentation. Now we switch to question. Please, if you have the question. Yes, Mr. Marwan, I have some question.
Yes, please.
The first one, why you convert original color image to a grayscale image to make segmentation?
This type we will facilitate, simplify the computing for the function, for the projection function. Just to facilitate it.
Okay. How you choose the parameters of your methods? Hidden, for example, number of hidden layer, activation function, or other parameters.
I have chosen them randomly.
Yes, and you compared the results obtained of different, for example, the hidden layer 500, for example, 256. If you compare the results or not?
I didn't understand you.
The results obtained, for example, you used the 3 hidden layer.
Yes.
I think 520, 256, and 128, I think.
Yes.
You compare the results obtained of different choice of this parameter or no?
I didn't hear your question.
We can change the parameters of the method.
Yes, there are several techniques to improve the training. In this work, the results obtained by this architecture was was good. We didn't change this parameter.
Okay, okay.
Yeah.
Okay. Thank you.
Thank you.
I have question, Mr. Nabil.
Yes, Mr. Hassan, you can.
Before,
You have
before to give the floor to Mr. Hisham, I have a question. So I'm asking Mr. Marwan for his use database. Is it freely
Yes.
downloadable from or you collect it yourself?
Yes, is open source.
Is open source.
Yes. You can find them in this link.
There is some link that you can.
Yes.
Okay. My other question is about the performance of your method, your algorithm.
Yes.
How did you? Is there some comparison?
The comparison is very difficult because the previous methods, there are methods which work just in 2 words, and the other methods work and on 100 words, and using different systems. For example, they based on the future extractor, and for our method is based on the deep learning technique. That's make the comparison is very difficult.
Okay. What about the calculation time? Did you have an idea about how long it takes? And some on some standard machine.
For example, in my machine, if we use a large architecture and a large data set, for example, if we use a million examples, maybe in my machine does make 1 year or more for the yeah.
You have to look for some powerful machine.
Yes, we have we need yes. This method is very difficult to for the training if we didn't have a powerful machine.
Okay, I'm asking you to look for some powerful machine in your university or online calculator and centers. So I'm asking you to add those in the next work. You add some comparison table of running time, RAM consumption, etc. It will be more informative about your algorithm.
Yes.
Okay.
Inshallah.
Okay. Now, Mr. Nabil, we give the floor to Mr. Hisham. Mr. Hisham, you can ask.
Mr. Hisham. Yes, he can ask question. Mr. Hisham, you have the floor. Thank you very much, Professor Hassan Satori, for your question.
Thank you very much, Dr. Nabil Aqad, Dr. Hassan Satori, for your animation. My thanks to Mr. Marwan for your presentation. Clear. I have just some remark and question. The first, how do you choose the weight of the neuron for the approach of neural network? The choice of weight is the arbitrary or we have a study about this choice?
No, it's just randomly. I chosen randomly.
After this,
I fixed this architecture because it have done.
As you know, the choice of this weight is very important. You can control the time of running and performance of your approach.
I can't understand you.
in based of this weight, you can reduce, you can have the time very reduced as our choice of the weight of neurons. Because
Yes, if we choose a short architecture, that we can reduce the time for the training.
okay,
But maybe that we can give us
yes,
a less performance.
yes.
Yeah.
My second question about data set Hadara.
Yes.
How many sentences or how many words of this data set? You can you don't talk about this data set.
This data set is contains about 18 image text.
18 image text about word or about image text?
Is text, image text.
How do you transform this text in the word? You make the segmentation.
Words. Yes, word segmentation.
But as you if you remark this the second line, you can look this approach of segmentation is not efficacious.
Yes, it's
because we can say two word in one segment. That's the problems of recognition.
I couldn't understand you.
The segmentation of any systems have very problems for recognition, as you know.
Our goal of this work is not to improve the segmentation technique, but
you need pass by this step.
Yes,
Okay. You cannot speak about the number of word in the training step and result step. How many words you chose in the training step?
We start with 10 words.
10 words.
Yes.
For training.
For training, yes. 10 different 10 different words. But for this work that I have sent to you, I choose just 2 words.
For recognition?
Classification.
For classification, you chose 2
words.
2 words.
Yes.
The choice of this word is arbitrary.
No, because the data contains a lot of them.
A lot of them. Yes. For my last remark, you cannot speak about comparison between neural network and convolutional neural network. As you know, for the second approach, we need a long data set.
Yes, in fact, we are trying to collect our data. The first one contains historical handwriting, and the second one, the modern.
Very good. Very good.
For the first one, we will contact the
just for training for training your approach convolutional in this data set. Yes.
I didn't hear you.
You can not hear me. Okay.
No, I didn't hear you. But can you repeat, please, your question?
As my tank, you just implement the convolutional network for dataset Hadara for training and for look how to turn this approach.
Yes.
Okay. What is the limit of your approach? This is my last question and my last remark.
What do you mean?
The limit, the problems you can not do
The problem is always about the data set.
processes.
For this architecture is very performance and powerful.
Thank you, Monsieur Marwan,
Thank you.
for your presentation and for your response. I wish you very bonne continuation.
Thank you.
Et je passe la parole à Monsieur Nabil et Monsieur Hassan. Thank you.
Thank you.
Thank you, Mr. Hisham Al-Mubtahij, for your very interesting remarks and advice and questions. So maybe we are almost consuming our allotted time. I'm asking Mr. We have two last questions. Please ask your question briefly because I got warning from the organization committee that we consume our allotted time for this session. Please, I'm giving the floor to Mr. Hamid and Mr. Brahim. First, we start with Mr. Hamid. Please, briefly, your question.
Okay, good morning. So I have a direct question. Firstly, why the size of the images, the input images are 100 by 100? This is the first question.
We can choose another shape or size for this.
So did you use other size? Why
Yes,
why you have choose this 100 by 100?
Just I choose them randomly. As I said previously, we can choose another size. But the problem of this methods is to choose a size like for example the weight is necessary to equal the weight.
Okay, I will switch to the next question. Here you have tested the two kind of neural network, the ordinary neural networks and the convolutional neural networks. I'm wondering about the convolutional neural network. Did you build or conceive from scratch your convolutional neural network, or because I didn't see that you have used the transfer learning, so you have developed your neural network from scratch? Is that right?
Yes.
So when we want to develop a CNN from scratch, it is not a very simple task, because we have some requirement. For example, we have to have enough data. We have to have computational resources. So how did you deal with those problems of data and the computation resource? For example, in order to train a CNN, you have to have a GPU.
As I said, I have done this training in my machine. For that, I choose a short architecture for both neural network and convolutional neural network to improve the performance of them. We can there are a technique called regularization.
Yes, regularization. Okay,
yes,
one more last question.
Sir Hamid, please,
just
briefly.
Briefly. How many parameters do you have in your model, in your CNN?
I forget that.
Okay.
But I think
Thank you, Mr. Hamid. We move to the last question from Mr. Brahim. Please briefly, you have your question.
Good morning, everyone. Good morning, Hisham. I have two little questions. The first, when you use your model for classification, you talk about 10 words and words. I wonder to know how many neurons in the output network layer, in the output layer.
Yes, for at starting or for in the beginning, we choose 10 different words.
Yes.
For this step, we attached in the output, at the output 10 neuron.
It's enough?
Yes, for 10 different words, 10 neuron in at the output is enough for 10 class.
Okay, with the database avec with a lot of words of Quran and Hadith, you have to have a lot of neurons in the output layer.
Yes, this technique is not for recognition, but is for classification. So when we give this architecture award, this have to predict the class of this word. If this
One
if
more
this word,
little question.
yes.
There are some work in some subject is in other techniques in machine learning. What is the advantage of your approach?
The advantage is run in real time. It's run in real time. It doesn't have or it didn't take a large time. And it is this type of technique is one of the intelligence techniques.
Okay, good luck in the future, and thanks the organizer.
Thank you.
Thank you very much for your question. I think that we have consumed the time devoted to this session, and we must switch to the last one.
One comment, please, Mr. Nabil.
Yes.
First, thank you, dear colleagues, for your interesting remarks and advices. Then we will take it in consideration in future work, inshallah. As Mr. Satori has said, we need a powerful machine to perform our work because we have a problem, some limits concerning this point. The machine used by Marwan is not enough powerful to execute and to have successful and good results. Secondly, Mr. Marwan is in his first year, and that is his first oral communication. I wish that he will respond and make a good work in the future. Thank you for your attention, and I wish a successful continuation for all. Thank you very much.
Thank you, Mr. Badr Aghutan, for your comments. So we move fastly to the last one. Abdulrahim, please upload your presentation, and you have less than 10 minutes for your presentation.
Okay, hello.
Upload your presentation. Mr. Abdulrahim, do you hear me?
Yes, I hear you. Now, good.
Upload your presentation. Hurry up.
Hello?
Yes,
Okay.
yes, it's okay.
Okay.
Go
It's
fast.
okay.
You can go directly to the fourth slide, because you got trouble from the fourth slide.
No?
Fourth
Okay.
one. Fourth one. Okay.
Okay.
Number 4.
Number 4. Yeah.
Okay. Okay, go ahead.
So, the importance of automatic speech recognition. Many systems are available that most popular are HTK, Darwin, Calvi, and CMU Sphinx. We found that the CMU Sphinx is freely available and currently is one of the most robust speech. In this paper, we work the creation of Moroccan dialects version of automatic speech recognition. So Moroccan dialect called Darija is the popular language broadcast in Morocco. Has 32 basic phonemes of which are vowels and 28 are consonants. The aim of this work is to create the Moroccan dialect automatic speech recognition and investigate the change that must be made to the model to adapt Moroccan dialect voice recognition. Our work will be based on the hidden motor model, HMM, and Gaussian mixture model combination. The proposed system will be designed by using CMU Sphinx. So this part represents our experience to build Moroccan dialect voice recognition system. As you see, this figure represents the main elements that are usually found in typical automatic speech recognition system. In the fluid picture extraction, acoustic model, and language model are described in details. Concerning feature extraction, technique transform the speech waveform into a sequence feature vector called acoustic vector. The most widely method of feature extraction is the near frequency spectral coefficient, as you see in this figure. The main goal of the acoustic model is to compute the likelihood of the observed feature vector given language units as form or T-form using a statistical method known hidden markov model HMM with mixture model distribution. As you see, this figure represents for each form or T-form. Language model gives the connection between words. Each word in the language model should be in the dictionary pronunciation. In our work, we use a grammar file, include 10 Moroccan dialects digits. Concerning the dictionary file is used as intermediary among the acoustic model and language model. As you see, this figure represents dictionary lists used in the training. So, this table shows the database preparation used in our experiments. For example, the sampling rate of the recording is 16 kHz with 16 bit resolution. And we use in training 14 speaker and 6 speaker in test. In each experiment, we use 3 HMM states and 5 HMM states with 4, 8, 16, 32 JMM. And concerning experiment results, in this case of the 3 HMM states, we find the best performance are 95.08% by utilizing for JLM, 96.27 when we use 8 GNM. For 16 and 32 GNM, we found 96.1% and 94.58% respectively. So we observe that each GNM gives the best rates when we use 3 HNM. When we use the 5 HNM, since the best results we were found with 4 and 8 GNMs. So, according to the analysis of digit integration rate, the most frequently misrecognized Moroccan dialect digits are sta and hamsa. In this paper, we investigated the speaker independent digit automatic speech recognition system using a database of sound corresponding to digits spoken in the Moroccan dialect. This system was implemented by using Carnegie Mellon University Speaks terms based on HLM combined with JLM. The best obtained result is 96.27%. The best performance the best parameterization is 3 HLM with 8 GLM. In our future work, the proposed system can be improved by using a large vocabulary of the Darija Moroccan dialect, and we test the performance of the system in a noisy environment. So thank you for your attention.
Thank you very much for your nice presentation, Mr. Abdelrahim. Now we switch to question.
Thank you, Professor.
Thank you. Please, if you have the question.
Yes, Mr. Hisham, you can ask your question.
Thank you, Mr. Nabil. Thank you, Dr. Hassan.
Thank you.
Thank you, Mr. Abdelrahim, for your presentation.
Thank you.
I have some question. Which type of dialect Moroccan your work? As you know, we have different dialectic Moroccan, Cassis, Marrakchi, Kazawi. I ask you about this different dialectic.
Yes. So we adopt Moroccan dialect for region the Fez.
Fez.
Yes.
Your database have different of this dialectic or beyond just dialectic Fez?
Is different because there are a lot of people different here in Fez.
Okay. About your model HMM, you don't talk about the number of states of your model. How many states are you using in this model?
I use
Yes.
three states and 5 states.
Why this choice?
Because the popular the popular HMM states use 3 and 5. Is the best performance.
I ask you if you have training with another number of states. You know, if you say about 80, 90, no?
Yes, I train eight states, but performance is bad.
Yes. And my last remark. Which type of HMM are you using? As you know, we have 3 types of HMM: discrete, continue, and semi-continue.
The discrete.
Discrete.
Yes, the discrete.
Okay.
You use thank you, sir.
Thank you, Prof. Nabil, Prof. Hassan. I wish you good luck.
Thank you very much. Thank you very much, Dr. Mubtahij Hisham, for your advice and question. I think that Mr. Ibrahim will ask a question. You have the floor, Mr. Ibrahim.
Okay, thank you. Good morning, everyone. Thanks, Mr. Hisham, for your presentation. Thanks for your supervisor, Dr. Hassan, and others. Your work, if I understand, can be classified as an ISR, automatic speech recognition, for developing a system from speech to text of dialect Moroccan using machine learning since you learn characteristic gene MFCC. My question is, as you know today, all researchers is oriented towards machine deep learning and vision training. Did you think that you will switch to this technique soon?
Yes, Prof. First, after to use deep learning, necessarily we try to use HMM, HMM and GNM.
Mr. Ibrahim, so may I have interact with you? So it's really a very interesting. Your question is really pertinent, and you have right. Yes, the actual ISR systems are converted now. People, lab and researchers are working now for using are switched to deep learning and convolutional neural network. Yes, you have right. We are moving to, because deep learning is giving really good results. But the problem of deep neural network and deep learning is the memory and the calculation consumption. It needs really some powerful machine, and now we are still using our PC and our standard calculators, and it works right now. We are finishing our research with HMM. It's still HMM. It's giving really very powerful results, and all compared to we can, the results given by the HMM, it can be compared to the deep learning and neural network algorithm.
I agree. I agree.
Your remarks is really pertinent, and you have right.
I agree.
We are starting to move to deep learning.
We are still in our laboratory working with PC, and our database is not enough. And I agree with you that we can still make research in machine learning before switching to totally to deep learning. Thank you.
We hope that our ministry give us the condition to work with those powerful machines. You know, it's really it's expensive, and we cannot have in our proper subventions. We cannot got those powerful machines right now. Maybe in the next future, when our laboratory will have this kind of calculators, we can test and work with this powerful algorithm and recent methods.
Open so.
Oh, thank you, Mr. Bright.
Thank you.
Mr. Nabil, is there some other questions?
Yes, Mr. Hamid Aksas has some questions.
Sorry. Je suis désolé de vous interrompre, mais là, on doit arrêter les sessions parce que il y a d'autres sessions qui attendent. Je suis désolé, c'est Hassan. Je suis désolé.
Ok, Mr. Abdouahed.
Aksas, Hamid, je suis désolé. Donc,
we should stop the session. I thank everybody for their patience to assist this session. So now I close the session. You have the floor, Mr. Abdouahed.
Thank you. شكرا. Merci, c'était Hassan, c'était Nabil, حفظكم الله.
Merci beaucoup,
شكرا. Merci à tous les participants.
Merci, Sir Abdurrahim. Merci, Sir Abdurrahim. Merci beaucoup.
C'est Hassan. Hassan.